Hi, everyone. Welcome to Lecture 5. So in this lecture, we'll be talking about monotonic sequences, um, limit superior and limit inferior, and also Cauchy sequences, which are very important. Um, and we'll be proving some basic theorems about them. So these are some of the some more properties of sequences that will make our discussion of sequences a lot richer and help us kind of classify them in a more interesting and more complicated way. So here in this section, I just want to introduce the concept of monotonic sequences, which is it's very straightforward actually, and we'll look at some examples. But really, this word, I mean, monotonic, the term monotonic, it really just refers to a sequence that is either always increasing or always decreasing. So that's basically the definition we make. So let's just go ahead and state it. So a sequence Sn is increasing. And sometimes we put the word monotonically before this. Monotonically increasing if Sn is less than or equal to Sn plus 1 for all n. And then the same thing is true, but monotonically. Sorry, this is monotonically decreasing if Sn is greater than or equal to Sn plus 1 for all n. Notice that these inequalities are not strict. So actually, increasing sequences are allowed to stay constant, and so are decreasing sequences. So in fact, a totally constant sequence, if the sequence is just the same number at every term, then that sequence would technically be both increasing and decreasing according to this definition. It's a technicality, but it's a good thing to be aware of. So yeah, these are increasing and decreasing sequences, and then we just say that Sn is monotone or monotonic if Sn is increasing or decreasing everywhere, right? So it's either all increasing or all decreasing. That's what this means. Monotonic means the sequence is either all increasing or all decreasing. So let's just look at a couple examples real quick. So something like, you know, and maybe you should just think in your head when I write down the example, try to think about whether you think it's monotonic or not. So something simple like 1 over n. This sequence is in fact monotonic. So this is monotonic, right? Something like n squared. And so this one, by the way, of course, is decreasing. This also is monotonic. Of course, this one is increasing. At least provided that n starts from some positive number. Then let's see, something like, you know, -1 to the n is not monotonic, right? Because sometimes it increases when it goes from -1 to 1, and then when it goes from 1 to -1, it decreases. So it's doing both. Or something like, you know, -1 to the n is not monotonic. You know, cosine of n pi over 3 or something is not monotonic. Anything that flip-flops or oscillates or whatever is not going to be monotonic, okay? Now, notice that this sequence here is monotonic and it's bounded. but this one is unbounded, right? So monotonic sequences can be either bounded or unbounded, right? Just because it's monotonic doesn't mean that it necessarily runs off to plus or minus infinity. It can be monotonic, but it can still just get, it can kind of slow down as it goes on, right? So anyway, that's monotonic sequences. In the next video, we'll talk about when monotonic sequences converge, and then we'll move on from there.